Hello students, in this video I will be discussing about the topic of binary trees. What is a binary tree? How to represent the binary tree, the different ways, how to do the traversal of the binary tree, how to construct the binary tree using some of those traversal methods, okay, and some operations related to binary trees. Okay, so here I will first discuss what is binary tree. So, a binary tree is a tree where there is a node called as parent node. There is a node called as parent node, and this parent node can have up to two child nodes. Up to two child nodes. Okay, so there is a tree in which there are different nodes. So I'll take one node into consideration, and that node, if I consider it as a parent, it can have up to two child nodes. Up to. What does that up to a child two child node see? If I consider this particular node, A. So this can be a binary tree. Why? Because this particular node A, if I consider it as a parent node, it has no child nodes. So it can be up to two. So if it doesn't have, then also it is considered. So here there is no child node. So then also it is a binary tree. Or I can take one node, parent, and I'll draw one of the child nodes. So here a parent is having one child. So if it is towards the left, of course, it is called as the left child. So this can also be considered as a binary tree. Likewise, if I take a node like this A and write the child node to the right, so this becomes its right child. So this can also be considered as a binary tree because parent is having just one child node. It can be up to two. So it can be 0, 1, then 2. Okay. 0, 1 or 2. So this has only one child. So this is also acceptable. Likewise, I'll take one more case. A, then two childs. One is your left child, the other one is your right child. So there are two child nodes. So this is also a binary tree. Okay. Whereas if I take this case, okay, so B, C, and D. See, parent A is having three child nodes. Three child nodes. It is a tree because there are nodes and there are child nodes, parent node, child node, all this. But then it can't be considered as a binary tree. Why? Because this particular tree is having at the most three child nodes, which is not acceptable. Are you understanding the concept of binary tree? So, a tree in which a given node can have up to two child nodes. So, it can be no child, it can be one child, or it can be two child. That is the binary tree. Okay, now I will do the next topic, that is binary tree representation. How to represent a binary tree? Very important. Kindly take your time and understand. So there are two ways for representing the binary tree. One is your array representation. Array representation. The other one is your linked representation. These are the two representations that you have. Okay. So array representation and linked representation. Let me first discuss array representation. Array representation. See, array, you know, right? It will be used for storing the elements of the same type. And how do you access the elements? By making use of the indexes, correct? Now, usually the indexes start with 0. So, can be 0, 1, 2, up to n indexes. Now, in case of array representation, when you have the index 0, leave this 0th index as empty and start filling the elements from 1 to n. One in some way. You have to follow some rules. I'll discuss those rules, but the 0th index should be left empty, and from 1 you have to start filling the values into the array. And usually 1 will take the value of the root, the main root. Okay, remember it so much. Let us start the representation. See here, I'll take one example. A, B, C, D, E, and F. These are my nodes in the tree. Now, how do I represent this using an array? If you there is one formula that you can make use of. Okay, what is that formula? If the root, oh sorry, if the parent, let me consider the parent as P, and its left child will be at the index 2 star P, and its right child will be at the index 2 star P plus 1. 2 star P plus 1. What does this mean? See, I told you that the root node will have the index 1. Let me use a different color. Wait. Okay. Index 1. So, this value in this case, okay, the parent is having the value 1. Parent is having the value 1. So, the left child means B will be at 2 star P index. That is 2 star 1, which is at the second index. Likewise, C will be at 2 star P plus 1. 2 star P plus 1, which is 2 star 1 plus 1, which is 2 plus 1 equal to 3. Okay. Every time you need not calculate. If you're getting stuck, then you can do. See, usually what happens is when I start the array representation, see this one. If there are 2 child nodes, this becomes very easy. It has to be a proper, sorry. Let me draw now the array. Okay, so array, I will represent it something like this. Okay, now I'll try to put the indexes, some indexes. If I need more, then I'll place it later. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, if you remember, 0th index is left empty. 0th index is left empty. Then comes 1, first index. If you remember, first index will be the root. So A comes here. Then its left child and then its right child. So according to this, your left child can be placed at 2 and your right child will be placed at 3. So no problem. B will come here, C will come here. Then again we'll go towards the right. B, then D and E. So D will come here, then E. But when it comes to this part, see here, after C, there should have been a left child. For the C, there is no left child, right? There should have been. So, you leave that space for left child empty. And then you write the right child like this. If you are confused with this position, just use that formula that I told, 2 star P. See, how does this work? So this will be a first node, this will be a second node, this will be a third, fourth, fifth. Okay, like this. So now parent is having the value 3. So left child should have been at 2 star P. So that is 2 times 3, which is equal to 6. And your right child should be at 2 star P plus 1. which is 2 times 3 plus 1, which is 6 plus 1, 7. Are you clear? Okay. And one more thing, if you want, you can remember that is at every level, right? This is level. So at this level, okay, it follows this principle 2 to the power of. So here what happens is this is 1. So it is 2 to the power of 0, which is 1 at this one. So next time it is 2 to the power of 1, which is 2 nodes. Then it is 2 to the power of 2, which is 4 nodes. And so on. Okay, let me take one more example. Okay, so let me show you the tree. A, B, C, D, E, F, and G. This is my tree. Now I'll try to represent the given tree using an array. So let me put some indexes. Okay. If I need more, I'll place it at the end. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. For now, I'll write these many indexes. If you remember, root node will be left, the first index will be left empty, then A will come into picture. Right? Then you try to figure out the left and the right child of A. So left child of A is B. See here, the right child is not present. It should have been there. So this one I will leave it free. Then I'll try to, so this level is done. Now I have done this level. Now this level. So if you remember, in this one there is only one node. In the next one there will be 2 nodes. Then there will be 4 nodes. Then there will be 88 nodes. And then in this level there will be 16 nodes. Okay. So what happens is when it comes to this part, so B and C. Okay. So sorry, B, its left child is C. So it will be placed here. And then its right child. Correct? Okay. Its right child. But then what do you think is the index of E? Remember, this is level 0. Okay. I mean, not the level 0, sorry, the first one, this one. Then there should have been 2 nodes, B and C. Correct? So let me, okay. Let me correct it, this one. Like this. Okay, so first level had only 1. Then the other level should have 2. Then the next level should have 4. Correct? 4. So C and D is done. Okay. Ideally, A should have had one more extra node and it should have 2 child nodes like this. It does not have it. So we will leave space for those 2 child nodes, this one and this one. Okay. Then we'll come to the next level. See, after C, we have its 2 child nodes. So E and F. Okay. Then what happens in this? There should have been 8 nodes. So 1, 2, 3, 4, 5, 6, 7, and 8. Okay. 8 nodes would come in that level, right? So what do you think is the space of G? Now, if you're getting confused, you use that 2 star P method. So this is 1, this is 2, this is 3, 4, 5, 6, and 7. Now for finding the position of G. Okay, so its parent is at parent is at 6, correct? So left child, its left child is 2 times 2 times 6. Okay, it is 2 times 6, but 1 minute, 1 minute. So this should have been 3, 4, 5, 6, 7. This should have been 9. This is 9. Because ideally there would have been nodes, which is not present, right? So this is 9. So it is 2 times 9, which is 18. So this should come at this position. Are you understanding? Because I have given these numbers sort of incorrectly. See, the numbers will be according to the nodes that would have been a situation of a perfect binary tree. That means we assume there were actually there were that many number of nodes. Okay, so if I take that same node, same tree, sorry, see, let me show you how this works. If you're confused, see here. This is G, this is E, F, C and D, B and A. See here, this is the parent node. It has 2 child nodes. It should have, okay, and this is 4 and 5. So this parent 3 should have had child nodes 6 and 7. Correct? Then this would become 8. This is 9. Okay. Then D would have 10 and 11. Then this one would have 13 and 14. Then this would have 15 and 16. This would have 17 and 18, and this would be 19. Sorry. Uh, if I take 0, okay. So this is how it works. Okay. Let me show you one more example. See, what about this type of tree? See, like this. What are these called as? These are called as left skewed trees, right? So left skewed trees. What do you think should be the positions of these? So this is 1. Okay. So 2 is here. Ideally 3 is not present. 3 should have been there. So this becomes 4. 5 is not there. 6 and 7 is not there. So this would become 8. Correct? Then 9 is not present. 10 and 11 is also not present. 13 and 14. 15 and 16. Okay. And this have been 17 and 18. Like this, it would continue. So when I'm trying to draw the array representation, so the 0th index is like this, left empty. Then at the first index, I would have the element A. Then at the second index, I would have the element B. Third one is left empty because no element is present. 4 will come, C will come at 4. 5, 6, 7, 8 is left empty again. 5, 6, 7, 5, 6, 7 is left empty. At 8th place, D will come. This is how you will do the array representation. Okay. You can take up some examples and try to do it. If you want to, if you want me to check the solution, then you can send it to me. Okay. Now, linked representation, the second representation, like the list representation, linked list I will be using. Linked representation. This is a second representation of the tree. It has a code also. And I will be using doubly linked list for this. Why doubly linked list? Because there are 2 child nodes, right? Your data would be here. Your actual data would be here. Then one pointer to your left child. And the other pointer is to your right child. One pointer to your left child. The other pointer is to your right child. Okay. So how does this work? Let me show you the C declaration of this. Okay, how to define? Sorry, not declaration, define. So I will use type def. I'll use struct node and I will use the second name called tree pointer. Okay, then I'll define the members. So one is your data part. We'll assume the data part contains integer type of values. Then we have two pointers. One is your left child. The other one is your right child. Left child and right child. But then what is the data type of it? Because it is pointing to a tree. So node. And the node is having the data type as tree pointer. I'll give the variable as node. This is how I can do the C representation. Let me take one example and show you how this works. So, I'll take this tree S. It has two child nodes T and U. Okay. Then V, W and X. Let me do the array representation first so that you can recall the things. So 0 will be left empty. Then 1 will come into picture. 1 S will be placed. Then it has two perfect child nodes. So U will come here. Then V. So 2 and 3 index. Now we'll consider the node. No, it is not U. Sorry. I have made a mistake here. So S is having first child as T. The second child as U. So that will come here. Then T is left and right child. T is having left child V. It does not have any right child, so you leave it as it is. Then come to the right part, that is U is the parent. So its left child is W and the right child is X. Correct? So like this. See, the disadvantage in this array representation is, see, here I'm not at the index 5, I'm not having any element, right? But then I am keeping a space reserved for it. So it is a wastage of memory, right? I'm not having the variable, but I'm allocating the memory to it. It's a waste of space. So in case of linked list representation, this can be avoided. See how this works. So linked list. So it's a list, okay. So node will be there. Doubly linked list. So like this. And S would come here, correct? Okay. And its left child is T. So no problem. T will come here. Like this. Its right child is pointing at U, correct? So U will come here. I will come back to T. This is done, and this is done. Now we'll come back to T. T is having a left child as V, correct? So I'll represent that V. Okay, but T is not having any right child. Do you see any right child for T? No. So right child part will be left as 0. Are you clear? Now let me come to the left part. U is there. U's left child is W and U's right child is X. Now W does not have any left child. It does not have any right child. Likewise here. Are you getting an idea? So this is how it works. Let me take one more example and do the array as well as the linked representation. So like this. Okay. So yeah. So let me first do the array representation. First one, empty. This is 0. Then A will come at index 1. Then its two left and right child will come. So B and C, that will come at 2 and 3. No problem. Now we will come back to the next step, that is B is left and right child. So D will come here and E, that is 4 and 5. Then C's left child. C's left child is F, so F will come here 6. What about C's right child? There is no right child, but you have to allocate the space. So here. Then we'll come to the next level. We're done with here. Then D should have been 2 child nodes. E should have 2 child nodes. Then only F will have 2 child nodes, right? So um, this one is 7. So this is 8. This is 9, 10, 11, and 12. Okay. So this is 1, 2, 3, 4, 5, and this is 6. So if you remember, parent, if it is P and the child is 2 times P, that is your left child. So it is 2 times 6, which is 12. Okay, so it should come at 12th position. So 7, 8, 9, 10, 11, and 12. So here is where G will come. Other places are left empty. This is your array representation. Now, linked representation. What you do is you take the root node, that is A. So A, its left child B, its left child is B, its right child is C, B's left child is pointing at D, B's right child is pointing at E, C's left child is pointing at F, C does not have any right child, so this part will be 0, and F's left part is G. And D does not have any child node in either end, so 0. Here also 0, and here also 0. Are you clear? This is how you do the two representations. I'll give you one example. You do the representations for this binary tree. Can you do for this one? Both the array representation as well as the linked representation. Okay. So this is the first part where we do the binary tree representation. Okay. We'll go to the next part, that is your traversal. Binary tree traversal. Very, very important part in the data structure, that is your tree traversal. Okay. And what is meant by traversal? Traversal is nothing but, if I have to explain it in simple words, traversal means you're visiting the nodes. Traversal of the node means visiting the node. So traversing an element means you're trying to access those elements. For any operation, it can be for any operation. Traversal basically means moving to that or accessing to that position and accessing the element in that position. That is what traversal means. And there are 5 types of traversals that you have to learn. Okay. So the first type of traversal is preorder traversal. The second one is Inorder traversal. Third one is Postorder traversal. Third one is Postorder. Fourth one is Iterative Inorder traversal. Iterative Inorder traversal. And the fifth type is level order traversal. Level order traversal. Okay, so these are the traversals. Let us start with the first one, that is my Preorder traps. Pre. Okay. So pre means first. Like, okay. Any node, okay, this follows this principle. See, first what happens is there are three things. Okay. One is your left child, then there would be root, and then the right child. Correct? Right. But in case of pre-order, pre. So we are considering pre with respect to root. So root will come first. Root will come first, followed by the left child, and then the right child. Pre, right? That's why. So we are doing the representation with respect to these orders. Pre means root will come first, followed by left child and right child. So in order, if you remember, the main value comes in the middle, right? So it would be root in the middle and left child to the left and right child to the right. Post order. Post means later. So root will come at the end, left child and right child will come at the beginning. Are you clear? So, and if you remember a tree, see if there is a node, if there is a parent node, and if it has a left child can be subtree, right? Left child can be the root of another tree. So, for example, here A, then B, then C, and take this part. See, A's left child is B, but B itself is another tree, right? So, iterative. So, this again has to be evaluated using that orders, right? So, we make use of a process called as recursion in order to do the tree traversals, because the same function that you apply on the root node has to continue to the child node also, because child node again can be a root, right? So how do I write the function? So I not the function exactly. I will show the function later. But how does the traversal take place? The traversals are done recursively. Traversal is done recursively. It is done recursively. First, in case of pre-order, you visit the node. You visit 1 minute. You visit the node. The second step is traverse the left subtree in pre-order, and then traverse the right subtree in pre-order. First you go to the root, then you visit the left subtree, then you traverse the right subtree. The right subtree is having the child node, then you will have to repeat the steps to the same pre-order steps on the left tree, left child. Okay, now I'll take one example and show you. See here, example. I don't know why is the ink so, yeah. I'll take the example A. So A, root node, 2 child node, B and C. Then there is D, E, F and G. D, E, F, G. Now how do you do the traversal? That is your pre-order traversal. Pre-order traversal. Okay, see, it follows this principle. What is it? Root, then your left child, then the right child. Okay, so we'll come to the tree. So first there is a root. A is a root, right? So A will be taken. Then its left child. So left child of A is B. Left child of A is B. Okay. But if you look at B itself is a tree, right? B is a root node, then D is its left child, and E is its right child. So this again will be considered as a tree. So look very carefully. B is the root, D and E is the left and right child. So the principle says root, then your left child, then your right child. So in this particular tree, I'll call this tree as 1. In that, B is the root, okay, and its left child, D. D is the left child, right? D is the left child. But check if D forms a new tree. It is, but then it does not have any child node, right? So you write D directly. Okay, so left child is written. Now you write the right child, that is E. Okay, then you come back to the this side. What is to the right? So this part is done. So root is done, left child is done, then to the right child. If you look very carefully, right child is again a tree. So C is the right child, and C is again a tree. C is again a tree. So its root will be written first. So root is C, its left child F, and then its right child. Okay. So you have to first visit the root node, then go to the left child. Visit the left child. But if left child is it is another tree, then you will have to do the procedure of pre-order on that left child. It's tree. Then go to the right child. Like this, you will have to do. Let me do one more example. Okay. So, yeah. I think if I erase, everything goes off, right? This is E. Oh, God. Okay, this is E. Okay, let me do another example. So, A, let me do another one. See, A, its left child is B, B's left child is C, its right child is left child is D. This is my tree. This is called as left skew tree because all the nodes are coming towards the left. Correct. Now, you have to follow that same procedure of pre-order. So, root, left child, followed by right child. Okay, so first root is A. So you'll write the root, no problem. Then you will come to its left child. Left child is B, right? But then B is itself another subtree. So this will be formed. So you will try to write its root. Then you will visit its left child. Left child is C. But if you see C is another tree like this. So you'll write the root and its left child. Are you getting? Let me do one more example. See. So A, B, C, D, E, F, and G. So how will I start? I will start at A because pre-order. So root will come first, pre-order. So root will come first A. Then its left child. What is the left child? Left child is B. So B will come into picture. B does not have any nodes, so no problem. Then you will come to the right side. So here, so you will write C, but then you will see that C is again a tree, right? C is again a tree. So you will write C. Then you will try to find out its left child. If you look very carefully, left child of C is D. No problem. It does not have any child node, so no problem. But when you come towards its right, okay, C is right child, that is E. You see that again it forms a tree like this. So E, okay, it's left child and it's right child. Are you understanding? We'll do two more examples just so that it becomes very clear. So 4, A, B, C, D, F, G, and H. This is my tree. Okay, so pre-order is first is A, root. Its left child is B, no problem. But then when it comes to the right, again, this is a tree, so C will come first. C's left child is D, but then D is again forming a tree, so D you will have to write. Then you will have to write its left child, then right child, and you will have to come back, and the only node left is F. Let me do one more. So A, then you have B, C, E, D, F, and G. Okay, so we'll start with this node, the root node. Start with the root node. So A will come here. A does not have any left child, so no problem. Coming to the right child is, sorry, A, then the right child is directly B. But if you look, B is again a tree, right? B is again a tree. So you will write its root. Its left child is C. Left child is C, but C is again forming a tree. So you'll write the root C and its left child, that is E. Sorry, it is not, it is C and then E. Likewise, you'll come to the right. Right is this part. So root, left child and right child. Are you clear? I'll give you one tree. You try to figure out the pre-order for it. It is A, then left child B, its right child C, its left child G, G's left child E, C's right child is H, and its right child is F. I'll give it like this. Or let me give the left child. Take your time. Do the pre-order traversal for this. Okay. You pause the video here and do the traversal, pre-order traversal. Okay. After you're done, then you continue the video. I'll give you the solution. If you're done, you can now start the video and check if this is a solution. A, B, C, G, E, H, and F. Is that what you got? If it is correct, then I assume you have understood the topic. Okay, next we will do the in-order traversal. In-order traversal. In-order traversal. In means root will come in the middle because in fix like the operators are coming in the middle, right? Like that. So the steps are like this. First one is you will traverse the left subtree in order. Then you will visit the root. And the third one is traverse the right subtree in N. Okay, let's do some examples. I'll take the same examples A that I've done for pre-order. D, E, F, and G. And second example is A, B, C, and D. Third one A, B, C, D, E, F, and G. Fourth one is A, B, C, then D, its left and right side, G and H. It's sorry. So B and C. C is left child D, then G and H. And here it is F. Then the fifth one A, B, C, D, E, F, and G. So 5 examples. I'll take a screenshot of this so that I can use it later, right? Okay, now let me do the traversals. So this is your in-order traversal. So in-order means visiting the left subtree followed by the root, then your right subtree. Okay, so let us start with that. So I'll consider this one first. So this is a root. So it's left subtree. Left subtree means this one. And right subtree is this. This is your left subtree and this is a right subtree. If you look very carefully, left subtree is again, it's a complete tree, right? So we'll try to do for this one. B, D, and E. So B is the root, D is a left child, and E is a right child. So it says traverse the left subtree. So D will come first because that is a left child. Then the root of it, that is B, and its right child. So D, B, E. Now this one is done. So you'll go back. So A is the root. So you've visited the left subtree. Now root is A. Now you will come back to the right child. Right child is having C. C is left child is F. Then right child is G. So the traversal says, the in-order traversal says first you visit the left child. Left child of C is F. Then the root is C. And its right child G. Are you getting? Now, if you want, you take some time and do all the traversals of these other trees and then get back to the solution. Okay. So what happens is next one A, it's left its child you have to traverse first. So B, this one, but B is again a tree, right? So what you will do? You will try to access C. So B's left child is C. But then if you see, C is again a tree. correct? So its left child. So D will come first, followed by its root. Okay, so this tree is done. So you'll come to this part. So C is already done, then its root. Then B is already done, then A. Likewise, let us do for this one. So this is the root, its left child. So B will come first, followed by A. Then when you come to C, C is again a tree like this. So C is left child D, then C. If you look very carefully, this is again a tree. So it is F, then E, then G. Again, let us do this one. So fourth example. So again, root is A. Okay. Sorry, you shouldn't write the root, right? So first is left child. So left child is B. Then its root is A. Then you'll come here. This is again a tree. So D is the left child. Its root is C. Then its right child. Again, you will come here. So, sorry, here there is a mistake. So, here. So, first is A, then its left child B, then A, then it'll come to this part. So, it says first is left subtree. So, D is again a tree like this. So, D, G, H will be considered now. So, left child is G, its root is D, and then H. Then you'll go back. So this tree, now C is the root we have and its right side. Okay. Next is the fifth one. So here A is the root, but then you will have to access the left child. It does not have any left child. So now directly access the root. Then come to the right child. Right child is this, but right child again is a tree. Okay. So B is the left child is C. Again C is a tree. So left child, then the root. Then you'll come back to this part. In that again, you'll write the root. Then you'll come to this part. Here F is the left child, then D, and then G. Okay. And fifth, I'll give the sixth one. You can try it. A, B, and C, G, H, F, and E. Try this one. Okay. Pause the video. Try this one. A is the root. So left child is B. B does not have any, B is having its own tree, but then B does not have any right child. So yeah, B. Then you will come to C. C again is a tree. And it is B, E, G, C, F, H, and then A. Check if you're getting the same answer. So that is how it works. Okay. Next one is your post-order traversal. Post-order traversal. Post-order traversal. Here you have to traverse the first step is traverse the left subtree in post-order. Then traverse, sorry, not traverse because, yeah, traverse the right subtree. Post, right? So root comes at the end. So right subtree in post order. And third one is visit the root. Okay, so you have to visit the left subtree first, then you have to traverse the right subtree, and then you have to visit the root. So now let me show you for these examples. See, it says visit the left subtree. See here, this is the root. Its left subtree is B, right? But B itself is another tree. So when B, D, and E comes, B is the root, and left child and right child is D and E. It says visit the left child. So left child is D, its right child E, then the root D, E, B. Okay, then the root, we are done with this. So you'll come back to the root. Root is A. Then you will have to visit the, sorry. Okay, so D, E, B. Then you will come to this part here. So in that again, left child is F. Then you will visit the right child, that is G. Then it's root C. Then you'll come back to this part and say A. Are you understanding? So can you try for the second one, please? Sorry, the second one. Second one should give you this answer. Check if you're getting this answer. Okay, third one. So tree is having the main root as A, and it's, sorry. So its tree is this one. So left child, right child, then the root, right? So left child, right child. So left child does not have any nodes, other nodes. So B will come first. Then C is a right child, but then C again forms a tree. Correct? So C's left child is D, and D does not have any nodes. So D will come first. Then you have to visit the C's right child, but right child is again a tree. So F will come first, then G, then E. This part is done. Now you'll go back to C and then A. Are you understanding? Now let me do this one. So A is the root, left child is B, so no problem, right root, left child. Then when you come to right child is again a tree. In that again, left child of that particular subtree is again a subtree. So now for this DGH, so left child, right child, root. This tree is done. So this is a root C. Not the root, sorry. So D, then it's right child, F, then C, then A. Likewise, fifth one, this is a root. So left child is not there. So directly go to the right child. Right child is this. Right child is again a tree. Its left child is again a tree. Also, its right child is a tree. So B's left child you have to access first. So in that, when you're trying to access C and E, E will come first. It does not have any right child, so C will come. Now I'll go to the right, this part. So here F, then G, left and right child, then its root. Then B will come, then A. This is how it will work. Okay. And can you try the post order for this particular example? Can you pause the video and do the post order for this one? The answer that you should be getting is, check if you're getting the answer like this. Okay. So that is pre-order, post-order, and in-order traversal. Let us look at the notes of this one. So traversal, binary tree traversal is visiting each node in a tree exactly once is called as a tree traversal. You have to visit the tree exactly the elements in the tree. Okay, elements are called as nodes exactly once. That is called as tree traversal, and there are five types. Sorry, pre-order, in-order, post-order, iterative in-order, and level order traversal. So, in case of in-order, you have to visit the left subtree in order. So, root will come in the middle. So, first traverse the left subtree, then you visit the root, then you traverse the right subtree. Okay, how the recursive function works? See here. In order is a function name, return type is nothing, so void. And we are giving the um, first pointer. Okay, so tree pointer. So if there is a tree, then there should be a value in the PTR, right? So we are using this as a node for this is like the pointer for the very first node. PTR is this pointer to the first node. So if this has a value, if there is a value in it, valid value in it, that means the tree is not empty. That means you can do the traversal. For in order, how do? You visit the left child. But then left child can be its own subtree, it can be its own tree, right? So that is why you will have to do the recursive in order call. So in order is called again on the left child of the PTR. After you're done with that, in case of in order, first left child will be accessed, then root. Root means root will contain the data parts, right? So you'll display it. Correct? And then you will also display you will do the in order traversal of the right side recursively. That is why it is shown like that. Okay. Next is your pre-order. Pre-order means root will come first, then the left child, and then the right child. Left child can be its own left subtree, and then there could be a right subtree. That is why I have shown it separately. So first, the function. So if there is a pointer means the tree is not empty. If the tree is not empty, that means you can carry out the traversal. So first is your root. In case of pre-order, first is root. So I am displaying the content of the root. TTR's data part. So if you remember, it had three parts, right? So this middle part is data. That is your root. Then you will pre-orderly traverse the left child and then pre-order the traversal of the right child. Likewise, post order also. Post order means first traverse the left subtree, then traverse the right subtree, then you visit the root. Okay. If there is a valid tree present, then you do the recursive post order on the left child and then the recursive post order on the right child, and then you will display the contents of the root. I hope it is clear. Fourth type is iterative in-order traversal. Iterative in-order traversal. So this one, it makes use of a stack. Okay, iterative in-order traversal makes use of the stack. See, the left nodes are pushed onto the stack. First, if you remember, a tree will have three nodes, right? Root, left, and right. So here, first the left nodes are pushed onto the stack. Okay, until the null node is root. That means you have reached the end of the left subtree. Okay, then the node is removed from the stack and displayed. You have to first access all the left side elements. Once you have reached the null, that means end, then you remove the elements from the stack and display all the left child contents. Okay, then again you do for the right child. That means you put the contents onto the stack till you reach the null character and then you pop out the elements and display. So initially, so we will be taking the node as a parameter. If it is a stack, top is equal to -1. And if you remember, this is your stack with the maximum stack size that can be specified. And we are calling the loop, which will explicitly, it will go on unless you break it. Okay. Now you have to, I said, if there is a left child, first you have to go to the left subtree and access all the nodes till you reach null, right? So that is done over here. If there is a node, okay, then how do you iterate? You have to go to the next left child. So nodes left child, if it is there, that becomes a new node. First, you push all the elements onto the stack. Once it is full, then you, that means when this condition fails, that means there is no left child anymore. That means you have reached the end of the stack. Then you pop out all the elements and then you display it. Okay. You go on doing this till the list is empty. So if there are no nodes, you break. Okay. Then you display the the root, and then you carry out the same on the right side. That is again, root node is, you will go to the right child and then put the contents into the stack, and go on doing this till the right child becomes empty, till you reach the end of the right child, and then you pop out the contents and display it. That is your in order iterative in order traversal. Likewise, level order traversal. Level order traversal is, you are suggesting the ordering, right? So based on that, you will be visiting the nodes. So let me show you the, see, first, this node will be, this level will be visited. Then all the elements in this one. So then this level will be accessed. So if you remember, first one will be placed, then 2 and 3, right? So what data structure can be used? So first element that was inserted is checked first. So which can be used? First in, first out, Q can be used. So I'm using Q for the traversal of level order. See, initially front and rear is 0. Then you decide, you give the stack size, maximum size. If the PTR is empty, that means if there is no tree altogether, then you need not do anything, right? If PTR is having a value, what does it mean by PTR? PTR will be pointing at the very first node, right? If it is not present, then you need not do anything. Otherwise, you add that into the stack. Then till all the contents are present, okay, you will go on putting the contents. Okay, then if there is a PTR, then you will print. See, it says level order traversal. So what I will do is, I will first do the data part, then I will do the contents of the left child into the queue, then right child into the queue, and then I will break the loop. Okay, so this is how it works. So we looked at the binary tree, we looked at the different representations of the binary tree, and also we saw the traversals of the binary tree. Since this video is getting a bit lengthy, so I'll continue the video in the next part. Okay, there we will be looking at the construction of the binary tree. Okay, so I hope you have understood. Kindly watch the video, learn from the video, do the examples. Okay. Okay. All the best.